All right, everyone, let's cover a really fun and exciting part of Spark, and that's Spark streaming. A little bit of background on Spark streaming. There's a wide variety of applications that may benefit from streaming, such as tracking the statistics about page views in real time or near real time analytics, collecting events to train machine learning models for product recommendations, or automatically detecting anomalies in applications or networks or anything that has data traveling through it. Let's cover the basics. What are streams? The data abstraction in Spark streaming are called DStreams. A DStreams is a sequence of data which arrives over time. Internally, each DStream is represented as a sequence of RDDs, which we've already covered. DStreams can be created from various input sources such as Flume, Kafka, HDFS, Kinesis, or even custom sources such as WebSockets. What can we do with DStreams? DStreams offer two types of operations, and this should look familiar to RDDs. Transformations, which yield a new DStream, and outputs, which write data back to an internal system. Outputs, as you've probably already imagined, are a lot like actions. In this section, how are we going to learn Spark streaming? Well, we're going to start with a few simple examples to warm up, or in other words, to build up our confidence and make sure our environment is ready to build a more advanced example. And that advanced example is part 2. We're going to write our own custom Spark streaming app using a Slack channel. Some more key fundamental concepts of Spark streaming include the architecture. Spark streaming uses a micro-batch architecture. This means computation is a continuous series of mini batch operations. New batches are created at regular time intervals, and this is configurable within apache-spark. There are two types of transformations, either stateless or stateful. As you can probably imagine, stateless transformations are simple RDD transformations. They're applied on every batch and have no regard to any previous or future transformations. Conversely, stateful transformations track data from previous batches and are used to generate new results from the batch executor. What are our next steps? We're going to dive into some really simple examples first, again, just to build up our confidence and make sure that our environment is ready to go. And then we're going to follow up with some more advanced examples. So I'm looking forward to it. I hope you are too. Let's begin.